Welcome to our deep dive into the fascinating world of data mining. When we look up at the night sky, we see billions of stars, each a giant furnace of nuclear fusion, emitting light and energy across vast distances of space. Data mining is kind of like that, but instead of stars, we have data points. And instead of telescopes, we have algorithms. Today, we'll explore various techniques and processes that help us uncover hidden patterns and insights from large data sets. Think of it like searching for constellations. We're not just looking at individual stars, but rather the relationships between them, the stories they tell. Just as astronomers use telescopes to study the cosmos, data scientists use data mining techniques to explore the vast digital universe. These methods help us make sense of the overwhelming amount of information generated every day, revealing hidden connections and unlocking valuable knowledge. So buckle up, get ready for a cosmic journey through the world of data mining. Imagine a tree, but instead of leaves, it has decisions. That's a decision tree in a nutshell. It's a powerful data mining technique that helps us make sense of complex data by breaking it down into smaller, more manageable chunks. Think of it like a choose-your-own-adventure book. At each branch, we ask a question about the data. Based on the answer, we follow the appropriate path until we reach a conclusion or prediction. This branching process continues until we've explored all the possible paths and outcomes. Decision trees are great for understanding how different factors influence a particular outcome. For example, let's say we want to predict whether a customer will click on an online ad. A decision tree could analyze factors like demographics, browsing history, and past purchase behavior to determine the likelihood of a click. And the best part? Decision trees are easy to understand and interpret, even for those who aren't data scientists. They provide a clear visual representation of the decision-making process, allowing us to see how each factor contributes to the final outcome. If one decision tree is good, wouldn't a whole forest be even better? That's the idea behind random forests, a powerful ensemble learning method that combines multiple decision trees to make more accurate predictions. Imagine a group of experts, each with their own unique perspective and expertise. When faced with a complex problem, they don't rely on just one opinion. Instead, they consult with each other, weigh the different viewpoints, and arrive at a collective decision. That's essentially how random forests work. They create multiple decision trees, each trained on a different random subset of the data. Then, when making a prediction, they aggregate the predictions of all the individual trees to arrive at a final, more robust prediction. This ensemble approach helps to reduce overfitting, a common problem in machine learning where a model becomes too specialized to the training data and performs poorly on unseen data. By combining multiple perspectives, random forests are better at generalizing to new data and making more accurate predictions. The human brain is an incredible organ, capable of processing vast amounts of information and making complex decisions. Neural networks inspired by the structure and function of the brain are a powerful type of machine learning algorithm designed to mimic this ability. Imagine a network of interconnected nodes, each representing a neuron in the brain. These nodes communicate with each other, passing signals back and forth to process information and make decisions. As the network learns from data, the connections between nodes strengthen or weaken, allowing it to recognize patterns and make predictions. Neural networks are particularly well suited for tasks that involve recognizing patterns in complex data, such as image recognition, natural language processing, and speech recognition. For example, a neural network trained on millions of images of cats and dogs can learn to distinguish between the two with remarkable accuracy. Just as the human brain learns and adapts over time, neural networks can be trained on massive datasets to improve their performance and accuracy. This makes them incredibly powerful tools for solving complex problems in various fields, from healthcare to finance to self-driving cars. In the vast universe of data, relationships between variables are like gravitational forces, influencing and shaping the patterns we observe. Regression analysis is our trusty telescope, allowing us to peer into these relationships and understand how variables interact. Imagine plotting data points on a graph, each representing a different observation. Regression analysis aims to find the line of best fit, a mathematical equation that represents the overall trend of the data. This line allows us to make predictions about the dependent variable based on the value of the independent variable. For example, let's say we want to understand the relationship between hours of study and exam scores. Regression analysis can help us determine how much each additional hour of study contributes to an improvement in exam performance. By quantifying the relationship between variables, regression analysis helps us make informed decisions and predictions. Whether it's predicting stock prices, forecasting sales figures, or understanding the effectiveness of marketing campaigns, regression analysis is an essential tool for any data scientist. Just as stars cluster together to form galaxies, data points often group together based on shared characteristics. Clustering, a powerful data mining technique, helps us identify these natural groupings within data, revealing hidden patterns and structures. Imagine a telescope that can automatically identify and group similar galaxies based on their shape, size, and luminosity. Clustering algorithms work in a similar way, analyzing the distance and similarity between data points to form clusters. For example, in marketing, clustering can be used to segment customers into groups based on their purchasing behavior, demographics, or interests. This allows businesses to tailor their marketing messages and product recommendations to specific customer groups, improving their overall effectiveness. From identifying fraudulent transactions to grouping similar documents for efficient information retrieval, clustering plays a crucial role in various applications. It's like putting a cosmic magnifying glass to our data, revealing the intricate patterns and connections that would otherwise remain hidden. In the vast cosmic web of data, seemingly unrelated events can be connected in surprising ways. Association rule mining is like our intergalactic detective, uncovering these hidden relationships and helping us understand the whys behind the whats. Imagine a supermarket checkout counter. By analyzing millions of transactions, association rule mining can discover patterns like customers who buy diapers also tend to buy beer. This information can then be used to optimize product placement, create targeted promotions, and ultimately increase sales. But it's not just about supermarket shelves. Association rule mining has far-reaching applications in fields like healthcare, finance, and even social media analysis. For example, it can help identify patterns in patient symptoms that might indicate a higher risk of a particular disease. By uncovering these hidden connections, association rule mining allows us to make more informed decisions, improve efficiency, and gain a deeper understanding of the complex interplay between different variables in our data. In the digital age, we're surrounded by a sea of text. From social media posts and online reviews to emails and news articles, unstructured text data holds a wealth of information waiting to be unlocked. Text mining is our linguistic key, allowing us to decipher this language of data and extract meaningful insights. Imagine a language translator that can instantly understand the sentiment, topics, and key themes within millions of documents. Text mining algorithms can do just that, using natural language processing techniques to break down text into its core components and analyze their meaning. For example, businesses can use text mining to analyze customer feedback from social media and online reviews, identifying areas for improvement and responding to customer concerns more effectively. Sentiment analysis, a key aspect of text mining, can determine whether a piece of text expresses positive, negative, or neutral sentiment, providing valuable insights into customer opinions and brand perception. From improving customer service to tracking brand reputation and even predicting stock market movements based on news sentiment, text mining is a powerful tool for navigating the ever-growing landscape of unstructured text data. Just as astronomers track the movement of celestial bodies over time, sequence mining allows us to analyze data that unfolds in a specific order, revealing patterns and trends hidden within the flow of events. Imagine a cosmic dance where each step influences the next, creating a complex and interconnected sequence of movements. Sequence mining algorithms analyze these sequences, identifying recurring patterns and predicting future events based on past behavior. For example, in bioinformatics, sequence mining is used to analyze DNA and protein sequences, identifying genes, predicting protein structures, and understanding the mechanisms of diseases. In web usage mining, it helps analyze user navigation patterns, personalize website experiences, and even predict future purchases based on browsing history. From understanding customer journeys to optimizing manufacturing processes and even predicting earthquakes based on seismic data, sequence mining unlocks valuable insights from the order and timing of events, revealing the hidden stories within our data. Time, like a relentless cosmic tide, shapes the ebb and flow of data, creating patterns and trends that offer valuable insights into the past and predictions for the future. Time series analysis is our surfboard, allowing us to ride these waves of data and navigate the complexities of time-dependent information. Imagine a graph where the x-axis represents time and the y-axis tracks a specific variable. Time series analysis helps us understand how this variable changes over time, identifying trends, cycles, and seasonal variations. For example, businesses use time series analysis to forecast sales, predict inventory needs, and optimize pricing strategies. In finance, it's used to analyze stock prices, identify market trends, and make investment decisions. Meteorologists rely on time series analysis to forecast weather patterns, track climate change, and predict natural disasters. By understanding the past and present behavior of time-dependent data, we can make more informed decisions, anticipate future trends, and gain a deeper understanding of the dynamic forces shaping our world. In the vast expanse of the cosmos, anomalies stand out like beacons signaling unexpected events or deviations from the norm. Anomaly detection in the realm of data acts as our cosmic anomaly detector, flagging unusual patterns or outliers that may indicate errors, fraud, or other critical events. Imagine a telescope equipped with a filter that highlights any celestial object behaving strangely, like a star suddenly changing its brightness or moving erratically. Anomaly detection algorithms work in a similar way, analyzing data for points that deviate significantly from the established patterns. For example, in credit card fraud detection, anomaly detection algorithms can identify unusual spending patterns that may indicate fraudulent activity. In manufacturing, it can detect faulty equipment by identifying anomalies in sensor data. Network security systems rely on anomaly detection to identify and block malicious traffic by spotting deviations from normal network behavior. By identifying these outliers, anomaly detection helps us prevent fraud, improve security, ensure quality control, and gain a deeper understanding of the rare events that can have a significant impact on our world. The universe is a high-dimensional place filled with countless variables interacting in complex ways. Similarly, data can become overwhelming with too many features or dimensions. Dimensionality reduction acts as our cosmic telescope, simplifying this complex tapestry without losing its essential beauty. Imagine compressing a high-resolution image without sacrificing its clarity. Dimensionality reduction techniques work in a similar way, reducing the number of features in a dataset while retaining the most important information. For example, in image recognition, dimensionality reduction can reduce the number of pixels in an image while preserving its key features, making it easier and faster for algorithms to process and classify images. In natural language processing, it can reduce the number of words in a text document while retaining its semantic meaning. By simplifying data without losing its essence, dimensionality reduction improves the performance of machine learning algorithms, reduces computational costs, and helps us visualize and understand complex datasets more effectively. Just as an astronomer carefully selects the right instruments for each observation, feature selection involves choosing the most relevant features or variables in a dataset for a specific task. It's about finding the right tools for the job, ensuring that our models are focused and effective. Imagine a toolbox filled with various tools, each designed for a specific purpose. Feature selection helps us choose the most relevant tools for our data analysis task, discarding irrelevant or redundant features that can hinder performance. For example, in predicting customer churn, relevant features might include customer demographics, purchase history, and engagement metrics, while irrelevant features might include information like favorite color or shoe size. By selecting the right features, we can build more accurate predictive models and gain a clearer understanding of the factors driving customer churn. Feature selection not only improves model performance but also enhances interpretability, making it easier to understand the factors influencing the model's predictions. It's like removing the cosmic dust, allowing us to see the stars more clearly. Before embarking on a cosmic voyage, astronauts meticulously prepare their spacecraft, ensuring all systems are in optimal condition. Similarly, data pre-processing is the crucial first step in any data mining journey, preparing our data for analysis and ensuring accurate and reliable results. Imagine cleaning and polishing a telescope lens to remove any dust or smudges that could obscure our view of the cosmos. Data pre-processing involves similar cleaning and transformation steps, ensuring that our data is consistent, complete, and free of errors. This may involve handling missing values, removing duplicates, converting data types, and scaling features to a common range. By carefully pre-processing our data, we lay the foundation for accurate analysis, just as a clean telescope lens provides a clear view of the stars. Data pre-processing is an essential but often overlooked aspect of data mining. By taking the time to properly prepare our data, we can avoid costly errors, improve model performance, and gain more reliable insights from our analysis. Before launching into the vast expanse of data mining, we need a clear destination in mind. Problem formulation is like charting our cosmic course, defining the problem we want to solve or the question we want to answer. Imagine setting out on a journey without a map or a compass. You might wander aimlessly, never reaching your intended destination. Similarly, without a well-defined problem statement, our data mining efforts can become unfocused and unproductive. Problem formulation involves clearly defining the goals of the project, identifying the relevant data sources, and understanding the constraints and limitations. It's about asking the right questions and setting realistic expectations for what data mining can achieve. A well-formulated problem statement acts as our cosmic compass, guiding our data mining journey and ensuring that our efforts are aligned with the overall objectives. It's the crucial first step in unlocking the secrets hidden within our data. And there you have it, a comprehensive overview of data mining techniques and processes. Whether you're a beginner or a seasoned data scientist, these methods are essential tools in your data analysis toolkit. Just as astronomers use telescopes to explore the vastness of space, data scientists use these techniques to navigate the ever-expanding universe of data. From uncovering hidden patterns and predicting future trends to understanding customer behavior and improving business outcomes, data mining empowers us to make sense of the world around us in profound ways. Thanks for watching, and don't forget to like, share, and subscribe for more insightful content. Keep exploring, keep questioning, and never stop seeking knowledge in the vast and fascinating universe of data.